everyone, my name is Caroline. I'm from the Federal University of Pernambuco, and today I'm going to talk about the production and application of graphene-based hydrogels and the continuous adsorption of dyes from wastewater. Water consumption is one of the most concerning environmental problems, and in this context, graphene-based materials are promising for water treatment because they present high theoretical surface area, good stability, low density, and high regenerative capacity. And they are also very versatile materials. On the other hand, agar, which is a mixture of natural biodegradable polysaccharides extracted from red seaweeds, has achieved commercial importance because of its gel-forming properties. And the polymeric chains of agar self-assemble into helical fibers that aggregate, forming a hydrogel. So the aim of this work is to develop an agar graphene oxide composite hydrogel, which is partially biodegradable, for dye removal from via fixed bed adsorption processes. We've done the scan electron microscopy of the samples. And for graphene oxide, it can be seen that the graphene oxide presented a slightly unrelated arrangement of multi-layer compact sheets. And for the 3 samples of the hydrogel produced, we can see here that in overall, all agar gel composites, there is evidence of a rapid thin geosheet which interacted with polymer that constitutes the matrix, which is agar, will result in a airy 3D disordered porous microstructure. In this case, we lyophilize the samples in order to proceed with the analysis. We have also done the thermogravimetric analysis and graphene oxide, for graphene oxide, and also for the agar graphene oxide samples. The 3 samples produced show that there is a rapid weight loss between 200 and 400 degrees Celsius, which is also attributed to the removal of oxygen functional groups. And a second weight loss was between 450 and 600 degrees Celsius, which was attributed to the decomposition of agar. We proceeded with batch adsorption experiments and using methylene blue in water. And for all the 3 samples, as we put more graphene oxide in the composite, the adsorption capacity increases. And on the other hand, evaluating the effect of changing the initial pH of the methylene blue solution, the adsorption capacity also slightly increases as we increase the pH. And from the fit of Langmuir and Freundlich models to the equilibrium isotopes, it is observed that it is noted that both Langmuir and Freundlich isotherms were well fitted with the data. And we also proceeded with some preliminary fixed bed adsorption tests for all the 3 samples. In overall, it can be seen that over 800 milliliters of effluent was treated in all cases. And the sample that presented higher mechanical stability and good adsorption capacity was the one produced with 20% of graphene oxide only. But in all cases, dispersion effects were very pronounced, as hydrogel is composed of around 98% of water, We also have these results on a dry basis, and for the 3 samples here, the adsorption capacities were over 450 milligrams per gram. Graphene-based compost was presented as an innovative and viable alternative for the industrial application of graphene in water and wastewater treatment. Thank you very much.